Okay, so in this video, we have a typical equation and we need to solve for a variable. Except it's not just a single variable equation or something like that. We have a bunch of exponents and stuff to deal with. But let's try to deal with this. So let me just rewrite this problem here. And when I look at these numbers, I can immediately think about something that they all have in common. So all of these numbers can be expressed as having a base of 4. So for this one, for example, this one's really easy. If we want to write this as a base of 4, we can just write 4 raised to the negative 1 and then raised to the 3z minus 1. This we can write as 4 as well, because 4 squared, and then z plus 2. Let me try to make my z's a little better. So let me write that 2 more curved, and then my z plus 2 is on top here. Multiply by 4, so 64, that's actually 4 cubed, right? Because 4 times 4 is 16, times 4 is 64, and then z minus 2. There's a lot of z's and 2's in this problem. Anyway, okay, now we can try to express this, we can try to write this as one exponent. So this is just going to be 4 raised to negative 1 times 3z minus 1. It's going to be negative 3z plus 1. This is going to be equal to 4 raised to the, this is 2z plus 4 right there. And then multiply this by 4 raised to 3 times z is 3z minus 6. Okay. My z's and my 2's are a little hard to differentiate between. Okay, so now what we have to do is we can combine these two here. Remember, whenever we have something like x to the a times x to the b, we can just write this as x to the a, not times b, but plus b. This is a rule that we have, right? It's an exponent rule. More practice, you can just get this memorized. Not even memorized, it just becomes intuitive over time. So let's do that with these, except we have expressions. So we can just add the two expressions. It's very easy, right? We don't even need to add any parentheses or anything. Those are added together. So this is going to be 5z. And then this and this are going to be added together. So that's going to be 4 minus 6 is minus 2. So that's what we end up with. Those are subtracted, of course. So 5z minus 2. So that's going to be 4 raised to the 5z minus 2 is going to be equal to 4 raised to the negative 3z plus 1. These you can just set equal to each other. Negative 3z plus 1 is equal to 5z minus 2. I'm trying to decrease the thickness of my pen. All right, let's do this. 8z, this looks better. 8z and then minus 2 is equal to 1. We can add 2 both sides. This is just going to be 3 is equal to 8z. And so z ends up equaling 3 over 8. And that you can't simplify any further. That's your answer. We can obviously do a quick check step, right? Our quick check step when we do this in a different color. So our quick check step here. And if we were to do our check step, we would have 1/4 raised to 3z minus 1. So that's going to be 3 times 3 is 9. 3, 6, 9 by 8 minus 1, which is going to be 1 by 8. Is equal to 16 raised to 3/8 plus 2. 3/8 plus 2, so that's going to be, let's see, that's going to be 19/8, right? So it's going to be 19/8. Let's see, 16 raised to 19/8 times 64 raised to z minus 2. Z minus 2 is going to be 3/8 minus 16/8, which is going to be 3 minus 16, it's negative 13/8. So this is negative 13/8. Okay. And then at this point, what we can do is we can express this is going to be 4, and then negative 1/8, and then this is going to be equal to 19. So this is, of course, 4 squared. So 4, I'm just taking up space here, but 4 squared, and then 19/8. So we can multiply the 2. So it's going to be 2 times 19 by 8. It's going to be 1. It's going to be 4. 19 by 4. And of course we have 64. It's going to be 3 times 3, negative 13/8 times 3, which is negative 36. Sorry, 39. Negative 39/8. Okay. 19 times 2 is what? So 19 times 2 is 38, right? 38. So negative 39 by 8, we can add this to 38 by 8, 38 by 8, which is equal to negative 1/8. Okay, negative 1/8. So this is going to be, at the end of the day, 4 raised to the negative 1/8. And that is, of course, equal to 4 raised to the negative 1/8. So this works out. So our answer ends up being 3/8. Now, you need to do this check, even though it might take some time. You got to do the check to make sure that you have that solution. Another thing that I wanted to point out here is the first step, we converted everything to have a base of 4. You can also convert everything to have a base of 1/4 if you wanted to. So you can leave this one alone. And I'm not going to do the whole thing. I'm just going to do the conversion and leave it here. I'll do this in red. So we can have 1/4 raised to the 3z minus 1 is equal to, we can obviously make this as 1/4 raised to, what's this going to be? Well, of course, it's 4 squared, right? 4 squared. So it's going to be 1/4 raised to the negative 2. That's equivalent to 4 squared. So this is negative 2z plus 2, right? Negative 2z plus 2 is equal to negative 2z plus 4. Instead of 2z plus 2, it's going to be negative 2z plus 4. So actually not negative 2z plus 4, negative 2z minus 4, because 1/4 raised to the negative second power is going to be 16, and then negative 2 times z plus 2 is going to be negative 2z minus 4. Yeah, this is it here. And then this is going to be multiplied by 1/4 raised to negative 3, right? Negative 3z plus 6. Negative 3z plus 6. Negative 3z plus 6, essentially, okay? Essentially what we're doing is, if you think about this, if you think about these here, these signs are just going to be switched because we have it in the denominator. When we have like exponents in the denominator, then we can bring them back to the numerator by making them negative or positive or whatever. We just switch the signs if we go up or down. So that's essentially something you got to know. Watch my exponents video where I cover that in more detail. But anyway, this was more of a, I guess, challenging problem that involves a lot of steps, but it was a good problem.